CNET stage, everybody, live here at 2013 CES. I'm Brian Cooley.
And I'm Lindsay Turrentine, Editor-in-Chief of CNET Reviews. You're watching us right now on a device that uses either a keyboard, a mouse, a touchscreen, or remote control. But imagine a world where all of those become obsolete.
Instead, you might interface with your electronics in the fairly near future by gesture, by voice, by eye movement, even by brainwave. That's why we think the next interface is actually you.
We have three guests who are making that a reality today. James Park is CEO of Fitbit, known for wearable tech that monitors your calories and your activity.
And right next to him in the middle of our panel is Matt Rogers. He's founder and VP of Engineering at Nest. We are both owners of said product, makers of a connected smart thermostat that figures out your behavior by figures out your home's HVAC behavior by monitoring yours.
And Michael Buchwald is CEO and co-founder of Leap Motion, which has created technology for operating electronics by just using your hands.
And I also want to point out we've got Brian Tong over here on the little dais right there, and he's going to be showing us some other fascinating technologies from Vuzix, the Muse brainwave sensing from Interaxon, and also iTribe's retina tracking technology. So we've got a very interesting array of tech for the next hour. First off, though, let's get things started. CNET's Kara Suboy will get our mental juices flowing on this remarkable trend.
The way we interact with technology is constantly changing, and the next interface is you.
Each other up. Yeah.
Google's Project Glass gave us a bird's eye view of the future of how humans will become one with technology. The glasses are outfitted with a camera and voice navigation to truly augment the wearer's reality. And when they become available to consumers in 2014, we have to ask, will we ever need or want traditional computer screens again? That's just one of several products transforming the human body into an interface. Someday, we won't need all those extras, like a mouse, keyboard, and screen to operate technology. Our bodies and gestures will do that for us. The video game industry pounced on this trend several years ago. Sony PlayStation, Nintendo Wii, and Microsoft Xbox all have their own motion-sensing devices that allow gamers to play without a wired controller. And now, you can play games with no controllers and only your eyes, thanks to a company called iTribe out of the Netherlands. A mobile device's camera follows your retina, instinctively knowing when to turn the page of a book or pop a balloon, making touchscreen technology look passé. When Leap Motion's Leap, that can read your finger's motion down to the tiniest wiggle, hits store shelves later this year, will the mouse and keyboard become completely obsolete?
It's about interacting with your computer in the same intuitive way you would interact with the real world.
And what about gadgets that are so in tune with our biorhythms? Devices like Fitbit that can find out more about our bodies in an hour than we've discovered in a lifetime. Or Nest's smart thermostat that learns your routine and adjusts temperature based on your daily needs. What are the limits of using the body as an interface with technology? And who's going to draw that line? Is wearable technology merely a passing fad? Or can these gadgets and their gamification help change our habits? And how do you protect a wearer's privacy? These gadgets, and more in the pipeline, are all attempting to change the way we interact with technology and travel through the world. But as they become less like props in a science fiction movie and more of a reality, we'll be forced to answer these important questions.
So let's ask you guys, just to kick this off, what are the benefits of connecting your body and your life and the hardware in your home to technology?
So for health and fitness, it's all about removing friction in logging your daily activity. So the first step in understanding and improving your health is knowing where you are and where you want to get to. And when we started Fitbit, a lot of the problems with existing devices is that it was very tedious to track things. You'd wear a device, you'd have to plug it into your computer, you'd have to remember to do a lot of things. With wearable technology that truly disappears into your lifestyle, tracking is something that you don't have to think about. It's just invisible tool or friend that just assists you on your goals.
Interesting. How about you, Matt?
So with interface design, you want to basically boil it down to its most basic components. What's the easiest way to do something? So it used to be, the technology we had, we do touch. Like the touchscreen was the easiest way to interact with your phone, with your device. But that's not necessarily a one-size-fits-all. So when we did Nest, we thought, well, what's the best way you want to interact with the temperature in your home? You just want to turn it. You want to turn it up and turn it down. And that's the most natural gesture for that. So we built an entire product around that gesture.
Interesting. Michael.
The philosophy behind Leap is very much letting people reach into their computers like we interact with things in the real world. And in the same way that my reaching out and picking up this bottle is a very complex but totally thoughtless action that's totally instant. That's the same experience that we want to bring to these unimaginably powerful computers that are literally everywhere we go.
Now, Michael, of all the technologies that we're seeing here, specifically at the stage with you guys, you're freaking people out the most. This is like as if it's by match. I mean, all this stuff's really impressive, but you were describing to me that hand gestures are not just very natural, but they're also they're high bandwidth in a sense. What does that mean when you're dealing with analog human hands?
Yeah, so it's all about letting people bring in the complexity. Basically, the fact that when I reach out and pick up this object, I am transmitting thousands of data points to my muscles in terms of how far forward I should move, how quickly I should move forward, when I should grab. And if we can let people bring that to a computer, and they can sit in front of something like a 3D virtual piece of clay, and they can sculpt that piece of clay with their hands and fingers, suddenly people who have never created anything on a computer ever can create a complex 3D model that's just as good as what someone would create who is a professional 3D modeler, and they can do that with no training and in seconds. And that same accessibility, that extends to all sorts of applications.
You know what's interesting here is that all of these panelists are taking us back to being children. Aren't you? Doing the simplest things and getting more out of them, in a sense.
Simple works. So.
Yeah.
Yeah.
I mean, one of the things that we thought about is not just children, but elderly. We want to build a product that works for everybody, and basically boil it down to its most base components. Yeah. I love it, actually.
Yeah, and if you watch a child, like an infant, interact with a computer or even a TV or anything, actually, their first instinct is to reach out and grab it. So it very much is going back to that most basic instinct, I think.
You know, one of the things I think about a lot is voice, which is not something that is necessarily integrated into the technologies that you're working on. But I have children, and I watch them laboriously learn how to write their thoughts down, how to learn how to type. Do you think that there's a future in which that type of spending years learning the mechanics of communication becomes less meaningful?
So, language is part of who humans are. And language is never going to go away. But the question is, can computers keep up? So this is a question that people have asked for tens of years. I mean, speech recognition technology is not new. And it's still not great. It's getting better, but it doesn't feel natural yet. You still feel like you're talking to a machine.
Yeah.
Now, if language is one of these sort of main touch points that we all know how to do, the other one is, visual is such an important part of all human senses. It's called the super sense in many cases. It's the one that we really, like television, we really kind of zero in and relate to and get so much richness out of. Brian Tong has got a visual technology. I want to go to him here. He's got, this is Vuzix smart glasses, the M100 smart glasses that are, they're an augmentation to a smartphone's interface. BT, tell us what these are. We can kind of see how you're wearing them there.
Yeah, so this is think of this as a heads-up display that's right in front of my eye, probably a couple inches, and what it does is that it links to an app on your smartphone and enables you to interact with your smartphone through a variety of apps. This is, again, the Vuzix Smart Glass M100. This is going to be different than Google Goggles, though, right? You saw the demos of how it was like a transparent heads-up display, where this is transmitting the video information from your phone, or whether it be email, photos, or movies, and then showing that in here. And I'm going to just take this off really quickly to see if you guys can get a little peek of this, to see if you can even get a peek of the screen. Hold on one second real quick.
Now, there's a tiny micro display in there. That's what we're looking at. There it is right there. Very hard to see. But that's replicating the smartphone display, right?
Exactly, and we have Matt Hallett over here from Vuzix, and we just wanted to ask, Mike, sorry about that, we just want to ask you really quickly, what do you see the future of this specific technology moving forward?
We ultimately see this as going to obviously a binocular technology, see-through, and we see this as replacing a cell phone one day. You don't need to have a cell phone. You don't need that screen that's in your pocket all the time. You have information access in front of your eye. It's going to be a natural ability to have that information on the go, and you can have all that technology right at your fingertips.
All right.
Yeah, it's different than Google Glasses. It looks like it might be similar, but it's actually a more understandable leap because we already know what we're going to see in it. Augmented reality is like another big jump that's almost the next step in many ways.
So I have a question about how the smartphone and mobile technology has made it easier for you guys to work on the innovations that you're working on. And is that a bridge to devices that have a feature interface, or is that how we're going to do it for a long time?
So for us at Fitbit, when we think about digital health, we want our devices to really disappear into people's lifestyles. And to do that, we have to make the devices non-intrusive, small, et cetera, but that runs counter to having an interface directly on the device. So we think of the smartphone as providing a really rich interface on top of tiny sensors, and I think that's a very good combination.
Yeah, actually, we took a lot of the same thought. So thermostats today have very cumbersome interfaces and lots of data and lots of buttons. But we have this great interface in our hands with our phone. So let's put the simplest things, the things that you need to use every day on the actual display itself on the thermostat, and have all the deeper kind of analytic features, how much energy you're using, how to program it on the phone. Like, let's use the right user interface for the right job.
That's interesting. And so, Michael, your technology skips that altogether, it seems like. I mean, does it render the smaller, tablet-style device not so meaningful?
Well, I think there are probably two steps. So immediately, a tablet that has Leap inside it could still have the same screen it has, but suddenly the interaction area can be bigger. Not just bigger, but also three-dimensional. So it's not just about this small 2D interaction surface that is the same size as this small screen. I'm interacting with my phone or tablet in this space between me and it, which opens up a lot of opportunity for new types of interaction, which is exciting. But we're also excited about enabling new form factors that wouldn't have been possible, like perhaps head-mounted displays, where the user's interacting with augmented reality in their field of view, in their vision, without strapping a keyboard or a touchscreen to their arm or something.
Let me ask you guys about a little bit toward your longer range plans. Leap Motion, as we've most seen it right now, is a module that works with other devices. The Nest thermostat, see it right there, it's a product into itself. Fitbit products are also products into themselves. They're all discrete. What's the integration plan? Don't all of you want to be out of the hardware business at some point and be licensing your IP? Matt, you're shaking your head no.
Never, actually. So
the thermostat is on my wall 25 years from now.
So I think so, actually.
Yeah.
So there's a natural progression of technology. But there are still some points in our lives where how we expect things to work. And those kind of shifts take a long time. I mean, thermostats have been on people's walls for 100 years.
Yeah.
We love being in the hardware business. We can add a lot of value that way. We can build something that's beautiful, something that's a work of art. I love being in the. It's one of our key differentiators. One of our key DNAs is, can we build something that's beautiful and easy to use that you want to have on your wall, as opposed to something that you just want to hide.
Matt, are there other Nest products in the pipeline?
We're always working on new stuff. With this team, there are many things that we could do. Michael, I got the impression that you were moving toward something much more of an integration with other product strategy, right?
Yes, both are going to play a big role in the future. We really like building hardware as well, and we like being able to create markets that didn't exist before, and obviously we can move faster than big OEMs. So we're going to continue to build products and create new markets, but we also don't think that users should have to carry around a peripheral to interact with every device. So the reality is, if we want users to use Leap technology to control their smartphone or tablet, and we don't want them to carry a peripheral around, we have to work with OEMs and we have to work to embed the technology. So both are in our future, and I think we can deliver great experiences.
And it would seem to me that the Fitbit almost wants to be part of my mobile device. Isn't it usually on me, and couldn't you build that into every phone, or maybe every phone and media player, because people still don't carry their phone to the gym all the time?
Well, I think the notion of interface is tightly linked with the issue of usability and wearability as well. So if you think about the smartphone, there's a lot of times throughout the day that it's not actually on your body. It might be on your coffee table when you go home.
When you're sleeping, right.
When you're sleeping.
It's really weird. You don't sleep with your smartphone in your pajamas.
A lot of women don't actually
in your purse.
in your purse, etc.
Oh, right. Yeah.
People, women don't have
Male blind
pockets,
spot.
etc.
Sorry.
So when you think deeply about the problem, you'll see that there's actually a subtle but important usability issue. And I think, again, the perfect combination is actually combining the smartphone with tiny sensors, using the smartphone as its rich interface, and using dedicated sensors as the collection mechanism.
So as sensors get smaller and probably over time cheaper and cheaper, is there a future in which we could have sensors in our clothes, or in any little thing you might have on your body while you're exercising or walking around?
I think that's ultimately where things will end up. I think when you think about embedding things into clothes, there's a lot of additional engineering challenges that you have to think about. But it'll be fashion challenges. But I think it'll be exciting for everybody to try to figure all that out in the future.
Now, it seems to me there's you all deal to some degree with the issue of signal to noise in the environment, because you're all working with an air gap to some degree, if I can kind of put it that way, with Leap Motion. Here you are making motions that have to be intercepted across space. Things can interfere. The thermostat can, it's got a motion sensor on it. If you folks haven't seen how this works, it detects when people move by to get a gauge on motion in the house. And the Fitbit perhaps could, has to filter out errant movements that aren't actually physical calorie expenditure. How do you deal with signal to noise when you're not hardwired in the traditional, motherboard fashion that everyone else is?
So I mean, a lot of it is just smart algorithms and analytics. With our motion sensor, we collected a lot of data, and over time, basically learned how to build the best algorithm on top of it. So AutoWay is the feature we use to basically turn down your house when you're not home. We launched the feature, and over the year, actually honed it in such that we learned your most likely occupancy patterns based on your motion. So in the morning when you leave, chances are you're gone. Either you went to school, you went to work, you went shopping, you're gone for a while. And that morning period is actually the best time to turn down the temperature because it's cold. So by basically collecting lots of data and performing analytics, we can figure out kind of the best patterns for that sensor.
Michael, how do you filter out someone next to me who's picking up a can of Coke while I'm trying to do my thing on my laptop?
Well, it goes back to the core philosophy about interaction. So if Leap was about these binary gestures where I make a sign with my hands and then something that's predetermined happens.
And that's kind of what the gesture-controlled TVs are doing, right? Pretty simple.
Right. When people think about gestures, that's what they think about. And we don't like that as much. We think that people don't really want to learn sign language to control their computer. So what we're pushing with Leap is the idea of interacting with something that is where there's context. There's an object, and you're interacting with it in this physical way. So we can ignore any noise that isn't related to some context. So if someone is sitting here and they're playing a harp in the air with their fingers, and you're moving your hand behind me and it's not anywhere near the harp, we can ignore you very easily.
Oh, interesting. So because the motions that you're reading and the way that you're doing it is so rich, it's easier to reject things that don't matter, right? I mean, if I'm doing a simple motion on a gesture TV to turn the volume up and down or something, and the cat jumps down from a bookshelf, that could be mistaken. It's the same thing, right?
Exactly. A gesture.
What you're doing is much richer and easier to distinguish.
Absolutely. A gesture TV is looking for, is there an up or down movement? Yes or no. We're looking for, how are you interacting with this specific contextual situation? And it's actually counterintuitive, but because we have so much more data and more accuracy, we're actually much more resistant to noise.
Interesting. Let's go back to Brian Tong. I think you are going to give us a look into your brain. This terrifies me, but let's do this.
We'll see how much activity we have there. I think it's a lot.
More than I want to know.
All right, so I'm here with Ariel. She's from Muse with the brain sensing headband. And tell us a little bit about this headband.
So this headband has sensors on my forehead and behind the ears, and it allows me to interact with content on my smartphone or tablet.
So this is an app right here, right, that you have, and when there is brain activity, you'll start seeing the peaks from that activity. Is that correct?
Yep. So what you're seeing here is actually my brainwaves. This is what it looks like inside my head. I'll blink for you. Blink, blink, blink. So you see that it's live and it's me.
I tried that demo and it didn't work for apparent reasons. So where do you also see the future of this technology moving for you?
So brain sensing technology has lots of advantages. The first one is that you can actually see what's going on in your own head and then do exercises to improve your cognitive functioning and reduce stress. So this is the first time we've been able to, on a personal level, see inside our own mind and use that information in some way to make our lives better. Ultimately, this is going to be another control interface, a way to control your home electronic systems, your devices, etc. That's in the future, but right now it's about being able to understand and improve the self.
And also, you know, it is a fashion statement. You guys were talking about wearable tech, right? Well,
Okay.
that's how I roll.
Yeehaw. Oh, bad
Yeah,
pass.
you're not getting
You like that eyebrow action for all you tech lovers out
Yeah.
there?
Not
Okay.
getting any brain waves, but getting some great
I
temple
should probably
waves.
stop that, shouldn't I, Cooley?
Yeah, you're making me nuts. Here's you guys have got a party. I'm not trying to invite everyone to Interaxon's party, but explain to us how the headband is going to be used to operate the beer keg. This is a great story.
We're at a CES VIP party tonight, and people are going to be able to pour beer with their mind. So as they focus on the beer tap, it pours a beer. When you're done, you just clench your teeth or sort of make a gesture like this, stops pouring, walk away, drink.
That's what I do
Pretty
in the bar
impressive.
anyway, so it works.
That's crazy. I love that. I was kind of wondering if any of you have ideas about really unique uses that you've heard from your users, you know, stories you've heard of wild things that people have done using your products.
Yeah, we had a user last summer, I think it was in Arizona, who sent us an email about this, but there was a big forest fire in his region, and he didn't know if his house was okay, if it burnt down, or what was going on inside, but he was able to open up his app and see, oh, that my house is fine, it's not too hot inside, my house didn't light on fire, everything's okay.
Interesting, yeah. He'd have seen like 134 degrees or
Yeah,
something
exactly.
if there was a fire nearby,
Or
yeah.
his internet would have been down, or something, you know, something would have been
Yeah.
different.
Yeah, interesting. James?
For us, you know, our device allows people to track their sleep activity, and you know, we had one family where the parents actually used that, gave the Fitbits to their kids, and used the sleep tracking as a mode of competition. So the kids would compete to see who would get to sleep the quickest, and who would wake up the fewest number of times throughout the night.
That is, I can say as a parent, that is genius.
Yeah. I think
That's
Lindsay's gonna go
amazing.
buy
I
a
was
whole
like, I
six-pack,
gotta.
yeah.
That's really great.
Michael, what have people done with Leap Motion that made you go, never thought of that?
Well, I don't want to spoil any of our developers' activities, but there's a ton of things that people have expressed interest in doing, and it's been really amazing to see the diversity. And I think the thing that's most exciting and surprising to me is just how every person is passionate about using this for something else. I think there is something that people feel they have been missing from their experiences with computers, and it's just very different from person to person. So some people are saying, I'm really excited that I will be able to, for the first time, edit video, edit audio. Others are saying, I'm really excited that for the first time I am going to be able to interact with all of the complexity of my social networking data in this really intuitive, powerful way. And then, of course, there's tons of great gaming things in the works.
And I'd like you also to explain a little bit or illustrate for us a little bit about the resolution of what you're capturing, because we're all used to touch screens where the resolution is not great. Trying to type on a touchscreen frustrates everyone. If you're a little bit off, it's too stupid to figure it out. And we're talking about coarse versus fine gestures. How highly resolved is your ability to know, if I can move my finger just as tiny as bit, you can hardly see it. Can you pick that up?
We definitely can. Our accuracy is about 1/100 of a millimeter. And I know that sounds excessive, but it's actually not. The goal with Leap is for you to feel like your arm is an extension of what's happening on the computer. And in order to actually feel that way, and to feel like this is a fundamentally better way of controlling and not just a cool gadget, it has to be extremely accurate, but also very responsive. The latency is almost as important as the accuracy. So
Right, it is, isn't it?
Yeah.
I've heard a lot about with tablets, a lot of the future innovation will be about the latency of the touch response as opposed to even the sensing of the touch response or the pixels in the display.
Yeah, that's one of the things very early on with the iPhone that we had to get right. It had to be super, super fast. So it's one of the reasons why when you swipe left to right, it goes left to right immediately. That latency is super critical.
Yeah.
And the human brain is very good at picking up the difference in latency.
And knowing that you're doing something synthetic and going, okay, this is laggy.
Yes.
Yeah, and you see touchscreen controller vendors competing on scan rates,
That's right.
basically.
Yes.
So.
So that's one of the things we're feeling when we're using a touchscreen is a little latency, even more than accuracy. Okay. The feedback loop is kind of off there. Let me ask you guys about getting the word out to customers. I know you're at various stages in your customer-facing life as companies. What works, or how do you get people to think differently about controlling things when they are very, in their minds, good at keyboard, mouse, and touchscreen because they've not known anything else? You say, what? Works great. How do you get them to sample, to think differently about that?
Yeah, so for us, I mean, we're in very broad retail today.
Yeah.
So you could walk in your local Lowe's store, or Best Buy, or Apple store and see the product, and a lot of times just try it. And the best sales for the product is actually using it, using it in person.
Yeah.
And as we've grown and gotten more product out in the field, when people walk into someone's house and they see a Nest in the wall, they ask, "Oh, what is that?"
Yeah.
And that's the best sales tool is seeing the product and using it in action.
Yeah, let me see your thermostat. You've got one here. It's charged up. It has a little battery. I'm going to get Lindsay's thoughts on this too, but the reason, in case you guys haven't seen this, one of the reasons I bought the Nest thermostat, which is $249, so not a cheap date as thermostats go, but of all the things I loved about it, being connected, you can operate the thing from your smartphone or connected device, that's great, and of course all the intelligence and the great interface they've got in this thing, but being able to turn to temperature, just like one of those ancient Honeywell button thermostats that cost $19 down at the hardware store. That was like, that's what I want. Because I'd had one of those push button thermostats for years. When you want to go from 62 to 69 degrees, it's 7 pushes, plus the 3 it doesn't register.
So going back to interface design, that's why we made it round. That's the most natural thing you want to do when you control your temperature. It's in our brains.
So Lindsay, what got you into the Nest? Because this is our little mini focus group of what got us into different interface.
Well, I reviewed it for CNET. So that got me, but I loved it. I mean, I became a convert, and people who review technology products are very cynical, right? I mean, and it was as easy to install as I mean, I did it, like on camera, and I like the way it looks. I like how easy it is, but I also really like the ability to change, and other thermostats have this functionality, but that's my house, by the way. That's my wall.
That's her hand.
That's my hand. I like the ability to program it from afar. And I don't do it that often, but when I need to do it, it's really nice to be able to do it. So, coming home from a ski trip and you're freezing and it's winter and you want to turn on the thermostat, or also being able to turn it on from bed. That's nice.
Right.
We were talking about this earlier, and our question was, right now, Nest, you can have 1 or 2 thermostats in your house to work on different zones, right? But it seems like there should be a future in which there's a much more nuanced interaction than just when I walk in the front door.
Absolutely, and you start to see this with products in the industry starting to be a bit more location aware. Did your car just enter the driveway? And you look at kind of the Ford booth, and some of the interesting things they're doing there is the connected car. So starting to think about how do all these things work together, and is there a possibility of your thermostat learns from your car? I mean, it's crazy, right?
Right. You're half a mile from home. You're headed in that direction. You're usually headed in that direction at that time of day. You're coming home from work. Right. Turn on the thermostat.
Exactly.
I'm going to ask James a question here. You guys are. Fitbit is arguably the nearest thing to a household word, I think, in this category of wearable fitness tech. I mean, this has been such an explosion here. You said what? Your area has doubled since last CES, you'd say? Yeah, this is a really big bump this year for the wearable fitness space. What is the next thing that you've got to get done to really make it not part of a panel about the cutting edge, but mainstream? How do you make that tip over?
I think it's a lot about consumer awareness, and there's a lot of different ways that we do that. So one is, there's a lot of retailers that actually, carry products in this category. When we started the company in 2007, I don't think there was a major consumer electronics retailer that carried digital sports tracking devices other than, Garmin's and Polars for the very high end. So in the past 2 years, retailers like Best Buy, Apple, Target, REI, these mainstream retailers have opened up this category, and I think that's really raised awareness of how these devices can help you. So I think retailers help, the media, consumer health is always top of mind of everybody, and especially with these tools, people can take control of their own health, which I think is pretty powerful.
Which one are you wearing right now?
I'm wearing the Fitbit Flex.
Okay, that's the new one. Hold that up and show the lights that it does to indicate what to you. I think our camera can zoom in and get there. Hold it steady right there. We see the LEDs moving. What do they tell us?
So basically, it's progress towards my goal. So you can set a step goal. I set something pretty achievable for CES, so it was about 10,000, and I think I smashed that by midday.
Yeah, it's easy.
So the display on the device gives you very quick feedback throughout the day, and if you want something more, you actually fire up your smartphone, and the device has been syncing in the background. So you launch the app, the data is already there. You can see your past history, your graphs, etc. And on Android phones, there's actually an NFC tag embedded in the device. So all you have to do with certain Android phones is just tap the phone to the band, and the app will automatically launch. So we're all about removing friction in the process.
So this tracks your activity, and what else?
So steps, calories, distance, your sleep quality, so how long it took you to fall asleep, how many times you woke up. There's a haptic motor in there for waking you up gently in the morning. So it also has a Bluetooth 4.0 radio, so it's always syncing constantly in the background. So it's all about, how do we create an ambient device that collects meaningful metrics about your daily lifestyle, and on mobile apps and on the web, provide tools to actually help you reach your goals.
I want to come back in a second. I want to ask you, Michael, about what will be the breakthrough for most people for your technology. What do you think is going to be the aha that might be the buzzworthy, hey, have you tried this thing? After we come back with this next demo from BT here, this is the iTribe technology. We mentioned this briefly at the open, using eye scanning to operate the mouse or maybe other parts of the interface on a piece of technology. Tell us what you're doing, and not that you're ignoring us watching a movie.
I'm not at all, Brian. So what this is the iTribe tech demo, and what it has here is initially you kind of calibrate. There's a camera on the bottom with LEDs on the bottom that detect where my eyes are. We're going to show you this, just an image of the screen right now in a second, just so you can see what it looks like, okay? So this is where you can see the little, my two eyeballs on the right-hand side.
Yeah.
Okay, so what I'm going to do is I'm going to swipe into an app. Once it calibrates that and knows where my eyes are, I'm going to jump in a game like Fruit Ninja, because I'm a ninja. But this time, I'm a ninja with my eyes. So we're going to get to there. And all I have to do is I just have to look at the fruit. Look at that, Cooley. You like that?
Seriously, wow.
Lindsay, you got some of that? Pineapple, kiwi, mango, lime, pineapple, kiwi, lemon, mango. So you're actually using your eyes as the interface to move. Right now, this is set to move the cursor around as if it was your watermelon. And, oh, there you go.
Okay, it's not voice technology.
No. I'm just saying it because I'm getting in the game, baby. I'm in. Look at that fruit. Uh-oh. You're distracting me. But that, it's an example of what we can see here. And we're here with Martin Tall, which is a very appropriate name here, right, Martin?
Yeah, that's appropriate. 6'4".
And Martin, just tell us about the technology and where you guys see it going.
Okay, so what we've shown here today is an add-on device for your tablet where you can actually control the interface straight. It's sort of replacing a touch or a mouse or something like that, but we see it being used all across the board, so just making the device a lot more aware of what your brain is actually focusing on. A lot of the cortex is actually dedicated to the visual system. It gives away a lot of your attention, what your motives are, what your interest lies. And I think this technology is enabling much more intelligent computers. They're just not sitting around and waiting for input anymore. They will know before you even know.
And then where do you expect to see this, this technology integrated? You're hoping to put it in other products in the future, right?
Right, so it's going to be desktop, laptop, tablets, smartphones, in cars, to see if you're falling asleep, if you're paying attention, and all that sort of stuff. So it's going to come into a range of products, and it's going to happen soon, too.
All right, excellent. All right, back to you guys.
All right, now BT, I have a question. When you were doing that, you were simply moving cursor with your eyes, and because of the way Fruit Ninja works, you didn't need to have any click command through your eyes, right? There's no click enabled at this point.
That's correct. I mean, if you look at it, where my eyes were pointing, it was kind of set with this game demo to kind of have a little a movement of a swipe already. So it was doing little baby cuts.
Yeah.
So whenever my eyes moved to that point, it was chopping up all those fruit.
Huh. All right.
You're jealous, aren't you?
We're always jealous of you. Michael, where we left off was, what do you think? Can you envision a time in the fairly near future where people are going to find one thing they kind of congeal around first and start to buzz about around technology like what you're doing and saying, okay, now I get it because I've tried X through it?
So I think there are two things, and I know that violates the spirit of the question, but one is that the moment someone gets a Leap and they connect it to their computer, they can use it to control Windows 8 or Mac OS 10 like it was a touchscreen. And even for legacy 2D interfaces, Leap can be a better way of controlling them than a touchscreen, because you don't have to move one-to-one like you do with the touchscreen. If I want to move from this corner to that corner, I don't have to drag, and I don't have to lean forward, which is tiring. So I can sit back comfortably, move my finger a small distance to cover the entire screen, but it's still a directed experience. So we think that will have a lot of mass market appeal, but it's about the developers. So the developer community is the single most important thing for us. We have over 40,000 developers from 150 countries that have applied to be part of the LEAP developer program, and the things they create, which a lot of which have a lot of mass market appeal. Those are things that are built to work great with Leap, and those are the first things where people are going to use it and say, wow, this is something that I never could have imagined doing before.
You know, Lindsay, I'm getting this vision of your army of editors, how they spend so much time hunched over, reaching, like Michael says, for a device they've got to pull, and we're dealing with ergo all the time like every company, getting in the right position so your neck's not stiff and all that. If we could just kind of sit back, I'm not making a pitch that you go, install 2,000 of these tomorrow. Theoretically.
I'm going to join the developer program. That's it.
Surprised you haven't already. It's a huge ergo breakthrough, it would seem, just for a way to get your body in the right position and not worry about, am I also in the right position to access the interface? It's just solved for one thing.
It's a potentially great replacement for something like a remote control, where you have to have a small but kind of not interesting device that sits around your living room. Instead of sitting, across the room and interacting with something on the other side of the room.
Yeah, definitely. We obviously you can use a Leap near a computer to control that computer, but you can also use it to control something that's far away. So we imagine use cases like a conference room where everyone has a Leap in front of them and everyone is interacting with the same screen.
So there's potential collaboration as well.
Absolutely.
Now, let's talk about the data that comes out of what all your companies are doing. We've got so much data from the way people interact with digital media today. It's an amazing groundswell in the last, let's say, 15 years generously. But if we look at any frontiers that are still untilled in user data that we have in the digital media, it's this stuff. It's body and gesture. We have no insight into that. All the data we have about users on the web, we don't know anything about where their arm was or what their body position was or what their sort of biorhythm state was when they saw something. This is like unlocking a new area of data, isn't it?
Absolutely. I look forward to the day where I don't need to go to the doctor anymore, but instead I'm told by my iPhone or by my computer, hey, we noticed something wrong, you're walking differently than before, you might want to go see somebody, and here's what you should tell them it is. And here's something you give them with all the data for the last 3 months that gives them a history.
Yeah, you could say you're putting an extra 8 pounds of pressure on your left hip, what's wrong?
See, I am afraid of being nagged. Did you guys hear about the haptic feedback fork? That
Yes.
on it vibrates when you're eating too quickly? I think I would just be like, you know what? I'm putting you in the dishwasher.
So technology again is supposed to mold to how humans already live. So it should never be too obtrusive. But and instead of having diagnostic medicine as it is today, where they just do a bunch of tests when you aren't feeling well, to have that diagnostic medicine happening through your entire life.
I think the key thing too is, if you watch the show House MD, House, one of his favorite lines is, people always lie. But if you are collecting this data and you do present it to your doctor, I mean, it's I think quite informative for the doctor to see how you have actually been living your life between doctor visits. I mean, what he's doing today is trying to make a quick judgment based on observing you for maybe 10, 15 minutes, asking you questions. But if he was supplemented by this data and possibly automated intelligence on top of that data, I think that would be a huge breakthrough.
And we all have such huge bias anyway about what we think we've done that led to ouch or whatever. We don't really know how we are. I mean, a question for you, James, about the Fitbit fits into a space, I think. Tell me if I'm crazy here. We're moving toward the 401k-ification of healthcare, where we have to become partners and be co-responsible for our health as we now are our retirement over the last 30, 40 years since that kicked in. Is that a trend you think is happening?
I think so. I mean, we sell a lot of devices to employers as part of their corporate wellness programs. And I think I hate to call it a partnership, but I think, it's good for both the employee. Yeah, it's good for both the employee and the company for you to be healthy. I would hate to see punitive measures ever taken, but I think right now it's all, everyone working together, opt in, and, let's get healthy.
Cool. All right. Any final questions or anything that we've left out? What have we left out? What have you thought? Why didn't they ask this? Why didn't they ask that?
So we get asked this a lot. Like, why don't you add this feature? Why doesn't it have a clock? All those kind of things. And part of what makes building a great device and building a great interface tough is dealing with all the noise and actually the discipline to keep it simple. And that's something to keep in mind, for all of us when looking at these next
attribute that serves you well.
Yes, yeah. When looking at all this next generation technology, keeping it really simple is hard to do, and that's something we need to do in order to really drive it to the mass market.
Yeah, Michael, final thoughts?
Well, I think in our case, it goes back to the importance of the developer community. We are very actively seeking new applications from developers of all kinds, and we will be continuing to send out thousands of Leap devices between now and when we actually start shipping the product.
Okay. James, last thoughts to leave us with.
For us, I think what we're going to see in digital health is, smaller and smaller devices collecting more and more meaningful data types, and I think it's a really exciting time because it's really in the past few years that technology has gotten to the point where devices like the Fitbit have been possible. So I'm really excited.
Mm-hmm. Yeah. Okay. Good stuff. I want to thank everybody for joining us for this panel. This has been, I know we like to think as an editorial organization, all of our children are beautiful. All of our projects and panels and pieces. This is my favorite so far at this show. So thanks everyone for being here. Please join me in thanking our guests, if you will. James Park from Fitbit, Matt Rogers from Nest, and Michael Buchwald from Leap Motion. Great future thinkers.
Thank you so much for coming.
And of
Really
course,
appreciate it.
thanks to BT and the companies that joined him there, Vuzix, Interaxon with the Muse brainwave sensing technology, and iTribe, the eye tracking and scanning technology. More great stuff there. How about a hand for them? Great innovators. Great innovators. On behalf of myself and Editor-in-Chief Lindsay Turrentine, thank you for being with us, and our live coverage at CES continues here at ces.cnet.com.